All right, today we're going to be having lesson 3.1 review worksheet. A little small hint for you to complete this assignment. I need you to write the vocabulary term for all the problems. So the majority of them you're going to find really quick. There's some, though, that you might have to then solve for X. So we're bringing our Chapter 1 skills back into play, and it'll be great. All right, so just really quick, remember you have parallel lines and a transversal. We should all know what parallel lines are. The transversal, that is the line that cuts across the parallel. So noticing here, if you were to label it maybe line A, line B, and maybe your transversal is T for transversal, or maybe it can be line C. Regardless, the one cutting across is the transversal. So it wants you on your instructions to talk about how these two angles are related. Essentially, why are they congruent angles? Remember, congruent angles are the same measurement. Right now, we don't know what the measurement actually is, but we do know that they are congruent. Our reason is, again, two parts. We would say that they are on the outside, and from yesterday's lesson, that is the exterior word. And they are on the opposite sides of the transversal. So this would be maybe the left side, and this is the right side of the transversal. And that word again is alternate. So our reasoning that these are congruent angles, it is an alternate exterior angles. And alternate exterior angles are congruent. So again, I am labeling the vocab term to tell why they are congruent. All right, let's try another one. So again, maybe I have line A, B, and then C here. Again, this is the left-right idea of the transversal. So if you notice, they're not on the alternate side because they're both on the right side of the transversal. So it can't be alternate exterior or alternate interior. And the reason, another reason is one is outside and one is inside. So it's not alternate, it's not exterior, it's not interior. So one of the vocab terms that we learned about, again, was referring to the same location. So if they're both on the right side of the transversal, and if you notice, they would be both above line A and then above line B, because again, this would be below line B. What's the term? So we would say that they are top or above and right. I like top right or right and up. Ooh, let's use those words again to connect it to our information from chapter 2. From the center, if you think about like the origin, it would be right and up. Right and up. And that is the same location, and that is called corresponding. So again, corresponding angles are congruent angles. Very nice, very nice. All right, for this one, again, they are already giving you the measurement. So remember that this is obviously going to be 67 degrees because you have your parallel symbols here. Another way, again, that they can say that they are parallel is it would say line A is parallel to line B. And sometimes it would actually say line A is parallel. Again, those are like train tracks to line B. This is our transversal C. So again, based off that information, line A, line B, and the transversal, those are automatically congruent, 67 degrees. So you have half of the answer. And again, we want our vocab term. Again, the stuff that I said at the very beginning, write vocab term for all problems. The vocabulary term, again, is, this is, okay, left, right. So one's on the left, one's on the right. And if you notice, they're both on what we consider the inside. So do you know what the term is? These are alternate interior angles. And alternate interior angles are congruent. They're both 67 degrees. All right, you got the parallel set up here. So let's say that this is line A, line B, line C. Now automatically this would be 134 degrees. Let's talk about this one for a moment. Now, if this was given to us, you know what, I'll save that. Let's just talk about this one real quick. These are considered what we call opposite angles. Opposite angles are congruent. Opposite angles, because again, if you were to maybe, let's see if I can group it and rotate it a little bit. Again, opposite angles are congruent. And there's another word for that. Maybe you know what it is, but I just want to show you why it's opposite. So if I were to rotate a little bit, it would say kind of like that this is top, this is bottom, opposite. Or the counterclockwise. This is on the left, this is on the right. So that's why we can call it opposite angles. Okay, so opposite angles are congruent, and the other word for opposite angles again are vertical angles are congruent. So if you say opposite angles, we're really talking about vertical angles. If you say vertical angles, then that really is talking about opposite angles. All right, very nice. All right, so this last set of your problems is, again, give me the vocab term, and then I need you to solve for x. So this is where our chapter 1 information comes into play. So instead of 23 first, let's actually do number 30 first, because this one will be easier to solve. So again, line A, line B, we can say transversal C or maybe transversal T. So again, we're going to say that these are congruent based off of the terminology, the vocab term, and then we'll solve for x. So again, this is the left and right of your transversal. So one is on the left and one is on the right. So that's the alternate idea. And then you ask yourself, okay, is it interior, is it exterior? They're both on the outside, considered for the parallel lines for A and B. So this is alternate exterior angles. Again, alternate exterior angles are congruent, which means if they are congruent, then I can say mathematically to solve for x that it is equal to. So I can say that these two angles, since they're congruent, I can say they're equal to each other, and therefore I can solve it. All right, so I'm going to give you a head start. Go ahead and solve for x. Again, it's just two-step equation. So hopefully you added 5 on both sides. So I have 15x is equal to 105. Again, this is from chapter 1. We're going to be solving equations all year long. Divide by 15. If you don't know what it is, you can go off to the side and guess and check. Now remember, you want it to end in a 5. So essentially it has to be an odd, right? So it would be a 5, a 7, a 9, definitely not an 11. So let's try a 7. 7 times 5 is 35. Oh, look, I have solved it correctly. Yay. So if I divide by 15, then that means x is 7. And again, if I wanted to check it, I can come back up here to this side, the 15x subtract 5. That again would be 15 times 7, which we already found to be 105. And 105 subtract 5 is definitely 100. So they are congruent angles based off of the alternate exterior angle theorem. And the value of x is equal to 7. Very nice. All right, so let's go back to number 23. Number 23 again, I'm going to set them equal to each other after I have said the vocab term, but this time I have variables on both sides, so I need to remember on which variable to move. Hint is a small one. So let's see. Parallel AB, transversal C, left side or right side. Ooh, they are on left and right. They are considered on the inside. So that again would be alternate interior angles. Alternate interior angles are congruent. So therefore, let's set them equal to each other. Just kind of experience here, I'm going to put 21x subtract 5 on the left and 19x plus 5 on the right. All right, so remember, we're going to move the smallest variable first, so I'm going to subtract 19x from both sides. So that's going to give me a 2x subtract 5 is equal to 5. I'm going to add 5 on both sides. Almost there. 2x is equal to 10. So x has to be equal to 5.
Will Allison McNaughton please come to the office?
Now again, to check it if you wanted to, if x is equal to 5, 19 multiplied by 5 would be a 95, plus 5 would be 100. And the reason I know that is because I usually have to count money real quick. So 19 times 5, that's 5, or 19 $5 bills, almost 100 bucks. And then over here, 21 times 5. Well, if 19 $5 bills is 95, then 21 $5 bills is 105. And if I subtract 5, that gives me 100. So they're both 100 degrees. And they are congruent. All right, the last thing I want to discuss will be your computer lab day tomorrow, dealing with some IXL skills. So look at this diagram. This is actually a problem that I took directly off from the IXL's page. So let's see what it says. If OQ, so this line here, and RT are parallel lines. So if I want to make it connected to, I can just put like a little A, B. Again, I'm just trying to make it look visible like this one here. So if you notice, this is the transversal, so I would say that this is C. Now again, you won't have the ability to do that on the computer, but since it's a screenshot, I can do that. Okay, so they're parallel lines. I got my transversal, and it says the measurement of angle OPS, and this is where a lot of students have difficulty, is trying to visualize where it is. So I'm going to be able to highlight it right now. On your screen on the computer, you can't. What I've seen a bunch of students do, though, is they've put their finger on the screen, and they've kind of moved it around to simulate the highlighting process. So the measurement of angle OPS, so it's talking about this angle here, is 115 degrees. It wants to know the measurement of angle TSP. So let me highlight it with a different color. TSP. It wants to know that. So if you notice, it's very similar to what we had on our worksheet, but you had to actually find which angle it's talking about. Compared to these, the angles are already given to you, and so on. So you have to do a little bit more of identification first. Now, some problems may ask again for your vocab term, and that's why we're focusing on those problems, identifying what it is. So if you notice that these are, again, left, right of the transversal. So that's on the left, that's on the right. They're both on the inside. Again, this is alternate interior angles. And as we remember, alternate interior angles are congruent. So the measurement of angle TSP would have to be 115 degrees as well. So in your little box that you would have down here below, you would type in the 115, hit enter. You don't have to worry about the degree symbol, and then you should be able to get it correct. Your SMART score will go up. Now, if it wanted the actual term, you would have to either select it. I don't think you'd have to actually type it in. But again, alternate interior angles, or maybe it's a vertical, corresponding, alternate exterior, and so on. Now, there's one thing I do want to mention, though, and this is in connection for stuff that maybe you saw last year, is let's say that it was talking about, again, OPS. And it says that that's 115 degrees. What would it be if it was talking about S, make that a little cleaner, SPQ? So that would be this angle. Interesting. Those are actually called adjacent angles. And adjacent angles means, again, they're just right next to each other. Sometimes adjacent angles are special, sometimes they're just next to each other. This here, if I had both angles together, it would create this full line. And do you remember what the angle measurement is of a full line? A full line is 180 degrees, and that is called supplementary. If it was two smaller angles, then it would be called complementary. And complementary is equal to 90 degrees. So since this is supplementary, which is the 180, and this is 115, how would you find this missing angle? Now, again, that's not this question that we started with. It's just maybe a different question that you might see on IXL. It's really just basic subtraction. 180 subtract 115. So if you have to do your borrowing, 10 subtract 5 is 5, 7 subtract 1 is 6, 1 subtract 1 is 0, or you can leave it blank. So obviously this would be 65 degrees because they are supplementary. If it was complementary again, that would be the sum, and it would be 90 degrees together. So maybe that's 45 and 45, 50 and 40, 30 and 60, and so on. But what you have here again is enough information to be successful on your IXL skills tomorrow in the computer lab. So your goal is to finish your assignment and then tomorrow be awesome in the computer lab. All right, be awesome.